All right, welcome people as you're joining us from all over the place. We will start this webinar here in just a few minutes. But as you're joining us, as you can see from the screen, webinar, so cameras and mics are off. But if you could go into the chat and click to make sure you're on everyone and put in the following information. Where are you from? And when does your school term end? Again, where are you from and when does your school term end? As you're just
Yeah.
joining us, find the chat, make sure you are on to everyone, and then put that in there. Thank you. We've got some people already putting that.
Yeah.
All right.
And Scott, why don't you answer the question for our listeners here? Where are you, Scott, and when does your school?
I'm located just outside the city of Chicago,
Okay.
and my school term ends on May 27th. How about
Awesome. About
yourself,
7 days.
Adam?
Yeah, I'm in central Illinois. So Scott and I have the Midwest covered here in Illinois. And I work at a university, so we're actually done. This is finals week for us. So students have left campus and we are wrapping up here. I see a lot of people here in the chat. We have people that are ranging from May 21st, but I do feel bad. I see that New Hampshire, Matthew, June 20th, Matthew. Ooh, that
Yeah,
goes late in the summer there,
it
Matthew.
is. It is. I'm hoping Matthew's school term started later also.
I
But
hope so. Maybe it's a year-round school as well. It has longer breaks. You'll have to let us know, Matthew, in the chat.
uh,
Yeah. Yeah. Oh, neat. So, and Jonathan from Vietnam, June 27th. So,
mhm. June
yeah.
17th. Oh, wonderful. South Carolina,
Yeah.
Jersey, ending this week. All right. Fantastic. Other people ending around the end of May, others into June. So,
Yeah, definitely. Yeah, and we hope that you all have earned a good rest this summer. I know it's school year is always a good journey, and often by now people are ready for that summer. So we thank you for joining us just for to learn a little more at the very tail end of your school year.
yeah. Matthew, thank you for the clarification there that you mentioned in terms of when you
Uh-huh.
started and things like that. So, oh, fantastic. Like I said, we're going to take about another minute and then we'll get started in on the webinar. We just want to make sure that people are joining us and that we can get started here pretty quick. Adam has put into the chat our participant agenda. We'll refer back to that later in what we're going to be doing here this evening where we are located. We know in other parts of the world that people are at, it is either uh, evening or it is uh, afternoon or it might be a different day. We know from people who are joining us from all parts of the world here. And we are so glad that you're taking time out of your schedule towards the end of your school term to join us to learn some about computation layer. This webinar is designed for educators who have had some experience with building in Activity Builder. This session is an introduction to computation layer. We're going to build sort of a foundation of a computation layer in our time together, gaining understanding of the big ideas of CL. So again, if it's your first experience of seeing L, you are completely welcome here. If you've had a little bit of experience with it, fantastic also. All right. So I think Adam will go ahead and get started
Okay.
here.
I'll go
So
on mute and I'll be monitoring the chat. Yep.
yeah. So Adam will be monitoring the chat, but I may bring him in by voice at times. And so Adam will be answering questions that you have as we're going throughout the evening, but we'll also have some time towards the end to answer some questions that you may have also. So again, welcome to Intro to Computation Layer, and just an introduction to that. And my name is Scott Miller. I'm located just outside of Chicago. Used to teach in Chicago, so shout out to Catherine there, 3.5 weeks to go for you also. Um, and I have until basically the end of May is when my school term ends. If you have any questions, feel free to email us at help@amplify.com. Or you can give us a tweet at Amplify or at Desmos Classroom if you've got a question that you've got there. So what we offer at Desmos Classroom is free classroom activities, free activity builder for teachers where you can edit and create your own activities. That's what this is part of this webinar is based on here. And again, that will always remain free. We also have a Amplified Desmos math curriculum, which is grade 6, 7, and 8 in Algebra 1. Those are full year based programs with standards based lessons and lots of other resources, both electronic and paper. And then we'll be adding to that of also geometry and algebra 2 in terms of curriculums and also and K through 5. So running the gamut of kindergarten all the way up through algebra 2 of curriculum. And again, that's a subscription based curriculum, but want to be also mention that the activity builder things that we're doing here are free and will always remain free. But the resources that you may see in terms of the Amplified Desmos Math, those are subscription based for your school maybe to be interested in. Want to be clear about what's on our agenda. We're going to walk through a few completed examples of computation layer. Then we're going to write some code together. And then we have some resources to send you off in your ways to expand your curiosity and explore writing your own code yourself and look at lots of other resources to do it. And I mentioned we will have some minutes at the end for some questions and answers, but feel free to drop some questions into the chat. Adam will be answering those as we're moving through. And if you missed, Adam is located in Central Illinois, and his school term has already ended. So kudos and fun for him. That everybody will be getting if you fill out the survey and stuff like that, you'll be getting a recording of this in the not too distant future within a day or two. So again, if it moves too fast or something, you can go back and watch that. Also want to be clear about what's not on the agenda. While Adam and I love teaching with Desmos activities, that isn't what this particular webinar is about. We have other webinars that are. It's not about advanced graphing techniques. It's not an in-depth course on computation layer. There are other that would be other types of webinar types of things. This is just an introduction. And again, this is not about learning about self-checking from computation layer. Okay. All right. So some design principles about Amplified or about Desmos would be creating opportunities for students to be right and wrong in interesting and different ways, giving feedback that attaches meaning to student thinking. So not to interrupt thinking, but to promote more thinking, creating a need for the mathematics, using a variety of resources and interrupting our biases about things. So you may see some of those design principles just in a few of the screens that we explore and then build together from computation layer. All right, so what I'm going to do here in just a minute is you're going to go through some screens of um, uh, activities, but it's not an activity itself, it's just some different screens. And what you're going to look for are what are the connections that you see on the screen or between screens as you're moving through. And there are 8 of them in total. So I'm going to jump over to that here in a second. So Adam, I know, is going to put into the chat here, joining the activity. Whoops. And that activity that we have listed there, just if you click on it, I'm going to jump over to what that activity looks like. I have you paused right now. But again, there are just several screens and there are 8 different connections for you to look for as you're moving through the activity. So what I mean by that from a student perspective is your first screen that you have is just sort of entering some things in to see what happens. There are 5 screens total as you move through. So I'm going to unpause you and then let you try those different screens and then see if you can come up with 8 different connections and just sort of remember them. I'm going to ask you about them in a little bit. So I'm going to go ahead and unpause you, let you jump into that activity. I will show you the screen that's there. I'm going to what we have, learning.amplify.com, or you can just click very quickly onto the link that Adam has given us. So again, 8 connections in total. And while you're moving through those screens, I'm just going to keep a summary to see where we're at as a group. And we'll have a few minutes while you're trying those different things. If you're just joining us in the chat, Adam has put a link to the activity that we're in. And your sort of responsibility right now in terms of the activity is just go through and interact with each screen and seeing what are the connections that are happening either within a screen or maybe even between screens as you're moving through them. There's only 5 screens total. Um, thank you for that question, Jorge. See if you can put something into on the first screen over in the table. See if you can enter a number in and see what happens. Okay. Yeah. So again, on the first screen, try entering in some numbers in for the radius and the height. See what happens. Oh, we're doing great. Just going to take a look at our summary here. We're moving through these well. Um, and again, so just trying to look for what are the connections either on the screen of things that are interacting with each other, or might be for one of the connections between screens that we're looking at. Oh, fantastic. Yeah, so just keep moving through those. We're going to take about another minute and then we'll share with each other what connections did we notice. Again, there's 8 in total that we have. All right, about another 15 seconds, we'll talk about the connections that we see. Okay, I'm going to pause us here in 5, 4, 3, 2, 1. If you could join my screen back over in the webinar, I'm just going to pull up the first screen that we see here. I'm just going to ask you here if you could just put into the chat what what's a connection that you saw on the first screen? So go ahead and type that into the chat. What is a connection that you saw on the first screen that we were looking at here? Go ahead and put that into the chat. All right, volume, good. Numbers make a picture. Wonderful. Yep. Dimensions, changes the shape, tables connected to graphs. Fantastic. Wonderful. Okay, great. All right, let's move over to the next screen in terms of screen number 2. Was there any connection that you saw from screen 2 onto screen 2 or somewhere else? Go ahead and put that into the chat if you could. All right, connects to the next page, connects to screen 3. My name appears on the third screen. Okay, great. Fantastic. All right. Then we moved over into this screen here. What was the connection that you saw? On screen number 3, besides seeing your name on the screen, was there any other connection? Yeah, connection of the buttons created an animation at the end. Yep, press that and then someone waves at us. Yep, there we go. Okay, let's move on to screen 4. And as you move the point to match the two lines, what happened? Any type of connectivity that you notice here as you moved your point? There we go. Lines moved up and down slope. Provides what we've got for the slope and the y-intercept. Great. Fantastic. Wonderful ideas that you came up with. All right. And then let's just talk about the last screen. We have a polar graph, and then we have a sort of Cartesian graph. What are things that you notice are happening here in terms of the graph? Okay, radius of the circle is the height. Previous one was talking about parallel and slope, matching the figure, points of impact on the rectangle. Yeah, terrific types of things that we are looking at here from our screen. So one is the radius in terms of the height, and then the other one in terms of our angle measure, change in terms of our width. Okay, fantastic. All right. So what we're going to do is I'm just going to pop over. Here are all 8 of those connections that you saw. So fantastic things that you all came up with. And so glad that we were able to notice all 8 of those. What we're going to move into next is actually how to build those and sort of talk about what are those types of things. So we're just going to explore the first screen that we had here in terms of some vocabulary that I'm going to use as we work through some introduction to computation layer. So I'm not going to build this graph, just going to use this example here to talk about 2 pieces of vocabulary that we have. And that is the following vocabulary of basically what is the graph getting from other components and what is the computation layer setting in the graph. Okay, so the 2 words that I'm going to use over and over and over again are getting and setting. And then what is the table getting from other components? And what is the computation layer setting in the table? So again, what is the graph getting from other components? What is the computation layer setting on the graph? And the same thing for the table. What is the table getting from other components? What is the computation layer in the table setting? All right. So what we have as far as what we're getting from the table is the value of cell 1 from the table and the value of cell 2 from the table. So we're getting those values over to the graph. And what we're setting then is the radius of the cylinder and the height of the cylinder. Now, if we look at the table, which was another component besides the note that we had, is we're actually getting and setting nothing from those. Those are just our inputs that we have, and they're pushing over to the graph is where we're matching or getting those ideas and then setting them in on the graph itself. So the table is what's pushing values over to the graph itself. So you notice the connections. What we're going to explore is actually, I'm going to build now. And so just watch along. You'll have your opportunity to build on your own in a little while is actually what we notice in terms of screen number 4. And that was the x coordinate of a movable point is the y-intercept and the y coordinate of the movable point is the slope. And that's what we're going to go ahead and start building here in just a second. So let's write some code. Okay, so I have here, and you'll have access to this yourself. Okay, is an activity. You actually will have more screens than this to build with, but I'm just going to do just a few to set you on your way, and then you will have resources from the agenda that Adam has that adds more screens for you to work with. And so what I'm going to show you is to do this, I need to make a copy and edit this particular activity. So what we have going on here is the following is we have where the computation layer is already written in the first screen. And in the second screen, it's no computation layer whatsoever. Okay, so it paired that way. Again, first screen has all the computation layer. Second screen has no computation layer whatsoever. So a couple of things to notice of how we come up with this is actually computation layer is the language that connects one component to another, whether it's on the same screen or on 2 different screens, like you noticed in the activity of where you wrote your name and it showed up in the third screen of what you were looking at, and typing in the second screen, showing it up on the third screen. All right. So, and where the computation layer lives, I just want to show you here is this particular green button. When we start working with computation layer, it changes, not green, but changes to teal in color. Okay. So again, this one has no computation layer here. This one has computation layer here. So let's sort of explore this example that we have to work with. So I'm going to preview what happens. So preview is when I move my cursor or my point that I'm looking at here. I'm moving it left and right. That's changing the y-intercept. When I move it up and down, it's changing the slope. Those are the things that we're looking at here. If I go to the next screen and I move that point, nothing's happening. There's no connectivity that I have or anything else like that. So what I mean by that is if I need to go back and look and I'm struggling with how that computation layer worked, to check it, I can go back to the first screen. We're going to explore starting on the second screen. So let's look at it in terms of those two things that we were talking about. So I want to look at of what I have is, so I've got no parameters assigned to any variables, and I have to look at it as, since we are setting in the graph on the right, okay, that is where we're going to be writing our code. Okay, so again, since we're moving a point that's here on this uh, graph that we have here in terms of our preview, moving this point, something should show up in this graph here over on the right. So that means where our computation layer is going to be coming from is from, we're getting it from the left and then setting it on the right. Okay, getting it from the left, setting on the right. So what I'm going to notice, you may have noticed here is I need to name my graph so I know where they're going, where they're coming from. So I'm just going to call this one here first. I'm just going to call this graph left. And then I'm going to call this one graph right. Okay, just so I can know where those are coming from to help keep things straight. Don't have to name every single component necessarily, but just to help me in terms of knowing what we're working with. Okay. So what I want to do then is we're going to help write and narrate in terms of what we're doing with this component on the right. So I'm going to, again, click on this edit computation layer script over here. Now, I'm going to start with some just typing some notes to help myself. This is not something you necessarily have to do. This is just to help to show you what's going on. If I use a hashtag, that means it's just a note. Nothing is going to happen in terms of the computation layer. So I can type in something like maybe Desmos rocks, or Adam is amazing. And you see, those are just grayed out in terms of script color. And this is sort of how I'm looking at my programming language of writing in computation layer. So I'm just going to write some notes here for myself. As it says, I want to get, or I want to set a number for the slope. Okay. And I want to get that number from the y coordinate of graph left. Okay. All right. So that's just some notes there. Not something that you necessarily have to do, but I find in terms of writing script is helpful for me when I want to use the programming language of computation layer. So what I want to do is I mentioned here is I want to work with setting that number for the slope. So I'm going to be working with what's called number. So as you can see, as I start typing, I have this number. Well, what is that number? So I'm going to go back out of this and go into that graph here. So I can just get hadit graph, and I'm going to look at what numbers I have. So I have this movable point x1, x1, y1. And over here on my graph, I can see that I'm going to set it for m as the slope and b is my y-intercept. Okay, so I'm going to jump back into my script, into my programming that I have. And so that number is what I'm going to set here is that number m. Okay, and that's going to come from graph left. Okay, that makes sense. And then I'm going to work with that in terms of what I've got for a number, placing that into in terms of x sub 1 that I've got here. And so when I type the, sorry, into the y sub 1 is what I've mentioned here. So again, what I looked at in terms of to get that number from the y coordinate on graph left. So I'm going to go y sub 1. So I have to do an underscore that I have here in terms of y sub one. And you can see I come up with an error message here and need to name that in terms of with these aspects here of grabbing that as a value, sort of what you might call from LaTeX. So this was the M that I was looking at, and then I'm looking at for the slope, and then I'm grabbing that from the y sub one value that I had over there. Okay. All right. So let's see what happens in terms of a preview. Okay. All right. So I don't have any connectivity that I've got going on here to look at. All right. And just gonna keep moving in terms of what I've got to work with. And then we're setting the slope from the y coordinate that we had from the graph on the left. Okay. All right. So what we're going to do then is now work with the other component that I want to do. And what one of the nice things that happens here is the following is I'm going to go ahead and copy this and then paste it because it's similar what I'm going to be doing for the next component. Okay, is I want to set a number for the y-intercept. And then I want to get that number from the x coordinate from the graph left that we're looking at there. Okay. All right. So what I'm going to do then is do the following is I can actually copy this, what we had from the coding. Whoops. Here, excuse me. Need to type that back in. Whoops. I think I crossed over that. Sorry about that. So number, and that was slope. I got that from graph left. And that was our y sub one value that we had here. Okay, all right.
I think you forgot the number dot number, Scott,
Oh,
after
I
graph
did.
one.
You're right.
Yep.
There we go. Okay. All righty. Oh, graph left comes after number after the graph left. That's right. That's what we're doing. There we go. Okay. All right. So sorry about that. I ended up pasting over that. Didn't want to. So I'm going to copy this and do similar what we're going to do down here in terms of instead of the slope, we want to set the y-intercept, and that's going to be x of one. Okay. All right. So those are the two things that we set up there. So again, setting a number for the slope, setting a number for the y-intercept in terms of what we've got for everything to work. And where we're grabbing it from in terms of the graph left and popping it into graph right is what we're doing. So that's why we're, again, working with our script and everything else like that in our graph right area that we're looking at here. So let's take a look at our preview. So now you can see everything is connected that we've got there. Okay. So again, backticks are needed and also needed in terms of just going back to that script is I need then sort of the underscore to get the superscript or of what we want is for y sub one and x sub one. So just to show you where those came from again, right here in the edit the graph, is that was the ordered pair x sub one, y sub one. And then if we look at our graph on the right, it was setting values then for the slope and for the y-intercept, okay, for the m and the b. All right. Okay, so now let's look at something else in terms of maneuvering things together that we have. And so let's take a preview of this one. So I have an image of a pencil. And if I hold down my cursor, I'm drawing with an image of the pencil connected to the sketch that I'm doing. If I go to the next screen with no computation layer, I do have where I'm sketching, but no connectivity to the pencil that we have. So we need to find a way of connecting these two things together. So let's talk about what we're getting and what we're setting from that aspect. Okay, so as you'll notice, so there's only one component on the screen, and that's actually the sketch that we have here. And I could take a look at the graph just to see some things. I have an x sub one and a y sub one in terms of the value, and then just an image for the pencil that we have. So in other words, what we want to do, looking at in terms of this connectivity that we've got here, is finding a way of setting sort of a number of the X coordinate of the image and getting that as the cursor's location. And then also doing the same thing of setting the Y coordinate and then getting that from the cursor's location of what we're going to do. So since this is only one component, I'm going to go right here again to the edit computation layer script. I'm going to go here. I'm going to type a couple of notes for myself. Again, not required. And again, we use that with the hashtag. So it is, I want to set the number of the X coordinate of the image, and that's of the pencil image. Okay. And then what I need to get that number from the cursor's X location. Okay. And similar to our previous one that we built and looked at for the coding was we had X sub one and Y sub one in terms of our coordinate that we had. So I'm going to go ahead and type in, and that's going to be a number is what I want to set. And that number that we're setting for is actually the X sub one. And what that's from is sort of from the current. And so it's that this dot current, and you can see X, okay? Current location of the X coordinate, okay? And as soon as I type that in, you'll notice sort of that error message. So there's some autocomplete that helps us in terms of writing with our code and computation layer. Much better than it was when computation layer was first put into place, when there wasn't that, so it's a lot easier to work with. So let's just take a look at the preview of what happens here, okay? So that means now I can maneuver going horizontally, but if I move my cursor vertically, no connectivity in terms of the pencil. But again, nice way of working with this is I can just copy all of this information again. And I'm just going to paste that in here. I'll automatically get an error message because I've repeated the same coding. But I'm just going to slightly modify this as I want to set the number for the Y coordinate and find that from the current location of the cursor. And it still have the error message because I've got this repeated of setting the number for the X sub one. I need to change this then to Y sub one and change this from current X to current Y. Okay. So let's see how that works in terms of what we had from our coding to see if it matches. So that preview button, now when we move the cursor for our sketch, the location of where it is on the coordinate plane of X sub one and Y sub one, the tip of the pencil matches that location the same place. Okay. All right. So just to sort of explore that then, what we looked at so far was in the first screen that we had here, we were basically taking in terms of this graph, the X sub one and Y sub one coordinate. And what we were doing is looking at ways to match that with the value for the slope and for the y-intercept. And our scripting that we had, that we wrote here in the code, was we had a number of what we were getting to set the slope, and that we were getting it from the graph on the left, and that was the y coordinate. And then we were, again, setting a number for the y-intercept. That was the b value, and we're getting that from the graph left, and getting that number then from the x coordinate. Okay. And then when we looked at something similar here of what we had in this component, we only had one component. We were looking at a connecting from the graph where we had the X sub one and the Y sub one, and connecting it then to the pencil tip location that we had here. And the way that we did that was somewhat similar to what we just did. In terms of setting a number for the X coordinate, setting a number for the Y coordinate. The difference though is that is where it was this current location of the X and the current location of the Y from the sketching component. Okay. All right. So, someone asked about, is there a list of functions and their arguments? Yes, we'll get to that in just a bit, but those are listed here in terms of our documentation, which I'm going to explore and expand. So appreciate that question. And they're listed here and some ways to do that. So tons of resources to help you. So let's look at then our last particular aspect or preview that we've got here. And that is, I've got a unit circle, and as I maneuver this point that's on the edge of the unit circle, it's tracing the sinusoidal function over on the right. And if I move it backwards, it unwinds what we're sketching of that sinusoidal function forwards and backwards. And if I move here, I do have the movable point around the unit circle. I do have a movable point for the graph, but they're not connected to each other. Okay, they're not connected. So I'm looking now at what am I getting and what am I setting? Okay, what am I getting and what am I setting? Okay, all right, so let's take a look at the components that we have. We have two graphs. So I'm going to name, like we did before, graph left and graph right, just to keep things helpful for myself. Now, you may have noticed back on the previous screens on 1 and 2, even though we named both components, we were only getting something from graph left. Again, I just find it's easier if I name both components, helps me in terms of keeping things straight from that type of thing. Okay. All right. So let's see what we're going to do. So we've got some complexity in the graphs that we've got here, but just a little bit of computation layer can go a long way to connect these components. All right. All right. So we've got then a variable on the left where let's just take a peek at the graph. Okay. If we look at what we've got here. So in other words, we've got this sort of angle measure of A that's maneuvering around on the circle. And then if I look at my graph here is then I've also then have how it's impacting how much of the sine graph or the domain value is being shown. Okay. So I know we're using the same variable A, but one controlling of the location of the graph on the left is then connected to show is what we want of how much of the graph is showing on the right. So the domain values that we're looking at here. Okay. All right. So let's sort of explore this. I'm just going to put into ask here in the chat, which component do you think we're going to do our computation layer in? Is it going to be graph left or graph right? Go ahead and put into the chat, which one do you think it is? All right. It looks like the winner is definitely graph right. Okay. All right. Okay. So let's go ahead and start writing our code in on graph right is what we're going to do. Uh, So I'm going to start writing here. Again, I'm going to write just some notes for myself, not required, just something that I find that's helpful. So I'm going to write in sort of a hashtag here. All right. Okay. So I want to set a number for the domain of the uh, domain maximum. Okay, just like of how far are we moving on that value as we're moving across from 0 to infinity. Okay, all right, and then I need to get that number. Whoops, a little misspelling there. From the angle in graph left. Okay, all right, so let's go ahead. Again, I want to set a number, so I'm going to use the number, okay, that I'm working with here. All right, and that number, hopefully you remembered from the graph left, that was A, okay? And then that was from graph left. All right, well, I'm wondering why, okay. So people ask about, I appreciate that Adam, you mentioned about best practice in terms of what we're looking at here. As you'll notice, I capitalize my graph left but it's giving me an error message. So let's see what the error message shows us. And that's saying, hey, oh, you only have graph, how you typed them was graph left and graph right. So I need to make that lowercase or select it right from here. Okay. And then what we're doing is we're setting that as a number on the sort of graph right in for A. So I kind of have to apologize that we're using A twice there. Um, but that now the error message goes away. So without the having the parenthesis that's there, now the error message goes away. Okay. Now, what's kind of cool about that is that number does both things, because if you saw from our components that we had over here of the graph left is we had that value of A was working for cosine of A and sine of A for our angle measure that we were working with. So we only need to enter that in once. Let's see if that works in terms of our connectivity here. There we go. So we're drawing our graph. So but so you notice we're winding around backwards behind zero, then and going negative, it's not showing on the graph because of our window that we have here. Okay. All right. Now, what I appreciate is what used to happen in computation layer, because I think people are wondering like, hey, Scott, you named back on screen two, you named those components the same thing, graph left and graph right. So what computation used to be is it used to be where we had to name those components differently in terms of what those were pulling from. So what I mean by that is used to be before, if I typed graph left, that would imply and would give me an error message if that was going from graph left here. Or in terms of the computation layer, what it would pull from would actually be from graph left all the way on screen one. Okay. Now, there are ways where you can do connectivity between screens, but now the default is actually it's kept contained within the screen itself to work through. So in other words, the naming of the components can help work with that. Now, I think Adam, you put into the chat, sometimes it's easier as you're building through several screens of maybe calling it graph left one, graph right one based on the screen number. That's another way to help things keep that. So yes, so each screens are their own unless we connect them with some computation layer between screens.
Right. And that's what I was trying to say, Scott. It was hard to type it in, is that if you're pulling something from other screens and that they're all named the same thing, it won't necessarily know which one you're talking about. So
Correct.
so
That
it becomes an issue connecting between screens, right?
between screens, yeah. So the default is that each screen is set contained on its own. So you can name components the same between different screens. It won't pull from another screen. When computation layer was first written, it would do that, and it was more cumbersome in that sense to work with. All right, cool. But yes, you are welcome to write more descriptive names to make it more sense to you, that type of thing. That is fantastic of how you work that. All right, so now to show you some resources, some things that we got. So again, this is just sort of what we have in terms of getting and setting. I want to show you some aspects of things that we have. So I'm wondering, Adam, if you could put into the chat the link of the agenda so I can explore some resources for people. I could do that. And then I will click on that to sort of show, there we go. Okay, so I'm going to go ahead and click on the agenda that you have. Okay, and just show you some next steps of what we're gonna do. Then we'll take a short survey and then answer some more questions. All right, so this is a blank copy of the activity that we just did, but I said that has more screens on it for you to explore. So I'm just gonna go ahead and click on that and let you look at it of it has all of the things that we built, the first 6 screens, but then it has several other ones for you to explore on your own in terms of connectivity and some other aspects of some other commands and other things like that. So we wanted to give you a preview of you to try things that we did, but then other things for you to explore. So let me show you what I mean by that. So if I click on screen 9, is there is a liftoff. Um, and so as I click on that button, then I'm getting sort of a liftoff of the graph that's happening. I have another one here where the cat's eyes are moving as it's watching the laser. And then another one here in terms of you can enter something into our table, such as maybe I want another fruit like lemon. And then it shows up of labeling over on the left. Okay. And then we have another connected one that we have here in terms of guessing a secret number to work with. Oh, watermelon. We can do that. Yes, we can. Wonderful. Okay. So again, that's for you to try. And a way to do it then is you'll go to the three dots and you will copy and edit this activity. And again, the first screen has the computation layer linked where all the components are showing what's happening. The second screen does not have the computation layer link. So it's for you to explore and try and see if you can come up with the connectivity that you see there. And what's kind of neat is actually the word Desmos itself actually means tying things together, binding things together. So computation layer and the word Desmos are actually synonymous with each other, connectivity. All right, so let's look at a couple other resources that you have. And that is the computation layer that you need. So I'm going to go ahead and click on that. And that's a list of what someone was asking, I can't remember which person or persons were asking about the different names of things that we are working with here. Okay. And so what we have is, I know we're saying getting and setting. What that ends up being is sinks and sources is sort of the vocabulary that's used in the language of computation layer. We find that getting and setting is an easier way to work with it, but lots of different options to work with. So if you want to explore, like, what does this do? So let's say I wanted to explore, we've been exploring number. Let's say we wanted to explore something on function. Here's the cool thing about it is I'm just going to click on this. And then this is going to set up of a very connectivity into the computation layer documentation. And so this has some more aspects of what the definition is, sets the output of a simple function to a variable defined in the graph. And then here's sort of the coding, an example of that. Function F, simple function, equation, input, LaTeX. And you might be saying, boy, that seems like a lot of, a lot of vocabulary there or words I'm not quite sure about. Well, the neat thing about it is if we click on this link here, it'll actually go straight to an example of how this is done. So in other words, this is a preview, and then you can go into exploring this. So if you type in a function here, such as y equals x squared plus 2, and you submit that, you notice that it's showing up of what the function is graphing from what we're putting in the math input over here. But I can copy this this screen, paste it into an activity builder, and then explore what's happening with the computation layer. Okay. All right. So here's the CL watcher that we're looking at. So just in terms of lots of things of links of working with here. So now when I jump back out of this, I'm into this screen. So again, that was the preview. And if I look at sort of the graph that we have here, we have a function f of x. And the computation layer is pulling a simple function that we enter in from the input on the right. And that's, you'll notice, is equation input is the name of our component. So again, just lots of resources for you to explore over time and to try things. So just going to go back to where we grabbed that from. That was in our CL that you need that has all the list. That connects then to computation layer documentation. Lots of different things to explore and learn about. But just want to show you lots of things for you to work with. Okay. Also, have some help that may be useful to you. is there is a support forum. I'm just going to click on that really quick. And you could type in a question of something you might have to search for. And there's lots of helpful people here. People who have lots of experience in computation layer, other people that are just trying out for the first time. You can put in and pop a question, and then people will answer that in sort of due time for that type of thing. Okay. Yeah. So again, just to clarify, thank you, is that to set something is a sync, to get something is where's the source from, is what we're looking at. Yep, that is correct. That's what we're looking at from that particular aspect. Sync and source. So where we get something from, that's where it goes. Okay. So again, lots of resources for you to look at. And a support forum find is very helpful when you're feeling stuck. Another thing to do is to actually, if you find something that you like a lot and an activity that you've seen, is actually to copy and paste that in screen into an activity builder yourself, and then try to construct it in a blank screen from scratch, and then try the computation because you can go back and forth. Very similar to what we set up here of this try it yourself, meaning where this is the one that is the connectivity, this is the one that doesn't. So trying to explore and take a peek at the computation layer that you're working with. Okay. All right. So I'm going to go ahead and show you then what sort of some things that we want you to do is a goal for you over the next summer is learn how to use 5 different syncs and learn how to use 5 different sources, and then maybe even learn about conditional statements. Just a challenge for yourself if you want to, or maybe it's just 2 syncs and 2 sources. Explore the agenda that we had from today's activity that we're looking at, the CL that you need. Okay, so we're going to open it up to some questions, but we want to put into the link here is just have you fill out a short survey. My name is Scott Miller, and this is Intro to Computation Layer. Okay, it's a short survey. It helps us know how we can do better. It also helps us, sending you a video of this webinar that we have here. But while you're doing that, if you think about a question that you have, feel free to put that into the chat. And then code about making different text colors. That is basically in terms of there's ways you can set things in the activity building yourself. You can set the pen color to a particular color or things like that. But just in terms of colors, I would go into computation layer that you need, and then something in terms of looking at color, and then go here. And it'll take you directly to where some information about that in terms of setting colors. Okay. All right. Oh, different text colors. That one is slightly different. Don't know if that's in here. Nope, not in there. That's a different approach, just in a note feature, in terms of how that's set up. Don't have that sort of set. I'm looking at it more in terms of how we can set the color for the graph or a point or something else like that. So the way that we look at in terms of building things, basically delaying feedback. So I want to show you back to the example that we were looking at here. Okay. And that was this one of our preview that we had, where we're typing in, y equals 2x plus 7. Okay. So it's building that in terms of an aspect of this connectivity of where our source is this math input that we have on the right, and then it's displaying it over here on the left. But what we would add into the graph would be a particular function that we want them to match. So I might type something in here such as y equals, let's say, 2x squared plus, let's go ahead and maybe in vertex form. So x minus 3 quantity squared plus 4. Okay. Maybe I want that to be looking that. Maybe I'll move it down slightly. There we go. Okay. So now when I look at a preview, is basically wanting to type, and I would change this of enter in what I would have here in the note would be is type a function that matches this graph. And then so then students use their work here, and then change what they're coming up with. Okay. All right. So just that's what I would say in terms of what we promote of delayed feedback, of working through. So then what students type then encourages them to think more because it'll display the graph that they have, and then now they'll modify what their thinking is to come up with it. Okay. Yeah. So people registrants will get a copy of the recording in the coming days is correct. Thank you, Adam, on that. Yep. All right. Yeah, so just put any other questions you have into the chat. If not, we are so glad that you joined us, taking time out of your busy day towards the end of your school term. We hope that things finish up strong for you and you have a wonderful summer coming up. Feel free to join us in future webinars. Uh, Feel free to drop another example that you've drop a question that you have, or connect with sending an email to us. I'll put that information back up here. Okay. You can contact us help@amplify.com. We'd love to hear from you. Connecting to different screens, that's going to be in here on the computation layer, or I would say actually into this one right here, as I would type in here the support forum. Okay. And then that's how you can, I think that's probably the best way to start there. So thank you for that question. Really appreciate that. Oh, thank you. All right. So in terms of typing in a compound inequality, it would be then in terms of finding some ways to display what that would be, to check for correctness then that way. So there's some Desmos activities you can look at on solving inequalities that would have some computation layer that would work on that. That I would say explore that, see if that sort of hits on what you're looking for, and then maybe there's some code that you can copy or edit from that aspect. Right. Thank you so much. So this other question here was, is there only graph left in the doc and its own on a different screen, the CL, it will take it automatically. I think if there's a graph left on the current screen, the CL, yes, that is correct. If you use a different name, it will grab it from another screen. All right. Thank you so much. Appreciate
And
it.
Scott, one question. Krista
Yeah.
had a question in the Q&A, and when you're typing, sometimes in the CL, it kind of pops up some green suggestions of
Yes.
other things. So she's saying hers doesn't suggest anything. You're not doing anything, right? It sometimes knows that as you're typing things in, it suggests
Yes.
different sources. So
Right.
Krista, I'm not sure why yours isn't popping up as you're typing. Maybe it just depends what you have typed in at the moment.
Mhm. Yeah, I think it's again the way it's used is if you start typing NUM, it's going to pop up with number. Start typing in FUN, it's going to automatically go to function and other aspects like that, and sort of some artificial intelligence built into it to sort of give some ideas. Is this what you're trying to come up with? All right. Okay. Well, thank you so much, everybody, for joining us. We're so glad that you were here. And we look forward to seeing you in the future. So have a wonderful rest of your day or evening or beginning of your day, and have a wonderful end of the term. And we hope you have a nice, restful break then, too. All right. So take care, everybody.